Section 3.4, question number 1. For the pair of functions, find the indicated sum, difference, product, and quotient. So we have f of x is equal to x minus 2, g of x is x minus 7. We want to find f plus g of 6. F plus g of 6 is basically f of 6 plus g of 6. And f minus g of 6 is f of 6 minus g of 6. So you see what's going on here. So it will be beneficial to find f of 6 and g of 6. F of 6 is equal to 6 minus 2, which is 4. And g of 6 is equal to 6 minus 7, which is negative 1. Now, 4 minus 1 is equal to 3. So that is the first value for the sum. And then the difference, f of g is 4 minus negative 1, which is 4 plus 1, and that is 5. So that is the difference. And then the product is f of 6 times g of 6, which is going to be 4 times negative 1, and that is negative 4. And then the quotient is f of 6 over g of 6, which is 4 over negative 1, that is negative 4. Similar is question number 2, so immediately I will find f of 7 and g of 7. F of 7 is 7 squared minus 2 times 7, and g of 7 is 2 minus 7 squared. So the first one is going to be 49 minus 14, which is 35. And then 2 minus 49 is negative 47. So now we want to find the sum. So f of 7 plus g of 7 is 35 minus 47 plus negative 47, which is negative 12. So this is actually plus negative. This is basically 35 plus negative 47. You just skip this step. And then f of 7 minus g of 7 is going to be 35 minus negative 47, which is going to be, which is 82. And then f of 7, times g of 7 is equal to 35 times negative 47, which is negative 1645. And finally, f of 7 divided by g of 7 is equal to 35 over negative 47. I can just leave it like a fraction. Question number 3. F of x is 2x squared plus 4. G of x is 3x minus 1. We want to find f after g of 3. So f after g of 3 is basically f of g of 3, which means we need to find g of 3 first. So g of 3 is equal to 3 times 3 minus 1, which is 9 minus 1, that is 8. So now this becomes f of 8, since we computed g of 3. F of 8 is basically, so f of 8 is equal to 2 times 8 squared plus 4. So 2 times 64 plus 4 is equal to 132. So that is the first answer for A. For B, we want to find g of f of 3, which is the same as g of f of 3, like that. So we need to find f of 3 first. So f of 3 is equal to 2 times 3 squared plus 4, which is going to be 2 times 9 plus 4, that is 18 plus 4, which is 22. So now this becomes g of 22. I know that g of 22 is equal to 3 times 22 minus 1. That is 66 minus 1, which is 65. That is B. C, we need to find f of g of x, which is the same as f of g of x, which means we're going to write each x in f of x as g of x. So this is going to become equals 2 times g of x all squared. So I just removed each x in f of x and replaced it with g of x, and then plus 4. Now I know what g of x is, so I'm going to replace it here. That is 3x minus 1 plus 4. Now we need to FOIL this because it's raised to the second power. So this is going to become 2 times 9x squared minus 6x plus 1 plus 4. I just FOILed it here. And then we need to distribute the 2 inside. So we're going to get 18x squared minus 12x plus 2 plus 4. Now we're going to combine like terms, which is those two. So now we have 18x squared minus 12x plus 6. And that is number C. Number D, we need to find g of f of x. So that is g of f of x. That means we are going to take each x in g of x and we're going to replace it with f of x. So this is going to become 3 times f of x minus 1 equals 3 times f of x is 2x squared plus 4 and then minus 1. So now we're going to distribute the 3 inside. So this is going to become 6x squared plus 12 minus 1. Combine like terms, which is those two. So we get 6x squared plus 11. And that is the answer for D. Number 4. Use the table to evaluate the expression f of g of 4. So let's find g of 4 first, because we need to work from the inside out. So let's find g of 4 first. G when x is equal to 4 is 3. So g of 4 is 3. That means f of g of 4 is the same as f of 3. I just replaced g of 4 with its value, which is 3. Now, f when x is equal to 3 is 5. So that is equal to 5, and that is the final answer.